and we're kind of going to talk about independent and dependent events. We call these, when we find these probabilities, we call them compound probability. So let's start out. We have a little bit of vocabulary that we need to talk about. And so the first thing is the word compound. So we're going to be talking about compound events. Compound events just mean two or more events that are combined into one event. So we're just combining two or more things into one event. So like our opener, we said, let's say we wanted to find the probability of rolling a 6 on a die and drawing a queen out of a deck of cards. That would be our compound event, rolling a 6 and drawing a queen. So anytime we're combining a couple of things, we're talking about a compound event. And what we want to do is we're interested in finding out these probabilities. To find out the probabilities of compound events, we use the probabilities of the individual pieces, and we combine them in certain ways. So we already know how to find the probability of one thing. We do the favorable over the total. And we do that for each part, and then we combine them together in specific ways. And we're going to talk about a couple different kinds of compound events. The first kind we're interested in is an independent event. And it means exactly event. There we go. It means exactly like it sounds. And this would be events because we're talking about more than one. The probability of one doesn't change the probability of the other. So, like our opener, the probability of rolling a 6 on a die and drawing a queen out of a deck of cards. Rolling the die doesn't affect the cards at all. It doesn't change anything that we do with the cards. So we would call those independent events. The probability of me going to Chipotle for lunch and the probability of someone getting a B on their LA exam, those two don't affect each other. Nothing's going to change the other. So we would call those independent events. The other kind is a dependent event. And those are just the opposite. The probability of one does change the other. So like our worksheet that we did over the weekend, if we have a bag that has different colored marbles and we take one out and we don't put it back, that changes the probability for the next time that we draw because our total is less. So we would call those dependent events. If we draw 3 cards out of a deck of cards don't put them back, and then draw 3 more, the total is less. So those would be dependent events. What happens for the first one changes the second one. So, just again, independent events, we pick a king from a deck of cards, and we toss a heads on a coin. Those don't affect each other. Yes? My E's sometimes turn out that way. What happens is I make them this way and then I loop it around too far. So they do show up that way sometimes. Yeah. I've been working on it, but it does still happen. A dependent event. So if we want to pick a king from a deck of cards, not put it back, and then pick an 8. Well, if I draw a king out, for my first pick, I have 52 cards to pick from. But if I don't put the king back, then I only have 51 cards to pick from when I do the second pick. So those would be dependent events. So we're going to figure out how to calculate the probabilities of dependent events, independent events, and then one other kind that we call overlapping events. So let's find out how we calculate the probabilities of independent events. Everybody good on what we mean by independent and dependent? Pretty much like they sound. So to find the probability of independent events, we usually say that as an AND probability. So the probability, we write it as probability of A and B, rolling a 6 on a die, and picking a king from a deck of cards. When we're finding AND probabilities, independent events, we multiply the two parts together. So probability of A times the probability of B. So the way I remember it is we have an AND probability, probability of A and B, means multiply. So we're going to multiply each part together. So when we have independent events, we multiply the two parts, the probabilities of the two events together. In the independent events, we multiply. So let's look at an example. So let's say we have on sheets of paper, we have the letters A, B, C, and D in a hat. So these are just written on slips of paper and they're in a hat. And we have a die. So we have a 6-sided die. We want the probability. We want the probability. Hello. So we want the probability of picking a B and rolling more than 3. So the first thing we need to do is we have a compound probability. We have two things going on at once. We want to know the probability of picking a B and rolling more than 3. So first off, does what I pick out of the hat change in any way what happens with the die? No. The die doesn't magically affect what I pick out of the hat. So these are going to be independent. So these are independent. And the other clue is we said and. Independent means multiply. So when we have independent events, we're going to multiply the probabilities of the two parts together. So first off, let's find the probability of a B. Probability of a B. What's our probability of picking a B out of the hat here? 1 in 4, right? We have 1 B, we have 4 picks. So the favorable over the total is 1/4. Probability of more than 3. So if we roll one die, what's the probability that we get a number more than 3? How many numbers are more than 3 on a regular die? 3, right? 4, 5, and 6. So that would be 3 out of what's our total? 6, and I can reduce that to 1/2. So the probability of more than 3 and a B, so I'm going to write it as greater than 3 and B, so that means greater than, right? Probability of greater than 3 and B is 1/4 times 1/2 or 1/8. And that would be my answer. So I have a 1 in 8 chance of picking a B and rolling more than 3. So we have independent events. One doesn't change the other. The other clue is we said and. We multiply the probabilities of the pieces together. Questions on that part? So looking for this and. The and means multiply. That's going to be a good hint. Usually they'll say independent events, they'll say and. And the hint that I give is and probability means multiply. All right. Let's talk about another kind of event. And then we'll calculate another probability. Mutually exclusive events. You'll see this come up every once in a while. It's more of a vocabulary word than anything else. Mutually exclusive events mean they cannot happen together. So if we have two events that cannot happen together, what is going to be the probability of the combination? We know that they cannot happen together. Probability has to be 0. That's what they mean. That's what we mean by they cannot happen together. So if we have mutually exclusive events, that means they cannot happen together. So the probability of the two happening together, the and probability has to be 0. So there's our exception to our and probability. They're mutually exclusive. The probability of them happening together has to be 0. So an example of that would be you get an A and an F on the same test. You can't get an A and an F on the same test. So those would be mutually exclusive. The probability of that happening is 0. The probability of the sky being blue, that wouldn't be a good one because that's the door being open and the door being closed at the same time. Door can't be open or closed and closed at the same time, so the probability would be 0. What would be another one? Rolling a 1 and a 6 in one roll of a die. So you have one die, you can't roll a 1 and a 6 in one roll. So that's impossible. So the probability of mutually exclusive events is 0. But we could talk about one or the other happening. We could talk about getting an A or getting an F. The door being opened or the door being closed. Getting a 1 or getting a 6. So if we're looking at one or the other, we're going to add probabilities. It can't happen together at the same time. So the probability of one or the other means we add. So they can't happen together, but one or the other could happen. So when we have an or probability means add. Yep, that's fine. Thank you. Thank you. So that's our hint for or probability. To say when we have an or probability, it means we add the probabilities of each part. So let's look at an example.
Still for independent variables?
Yes. So we're still talking about independent events. They're mutually exclusive, so they can't happen together. But we can find the probability of one or the other. We'll talk about finding the probability of dependent events a little later. So for my example, we have a bag with 4 red, 6 blue, and 5 green marbles. When we talk about probabilities, bags of marbles come up often. So these are what's in the bag. So what we're looking for is we want to pick a red or green in our first pick. So our first clue is the word or. Problem says or. It also, we can't pick a red and a green. If we're picking one marble, we can't pick a red and a green all at once, can we? We can only pick one. If we're picking one marble, it can't be both red and green. There aren't any marbles that are red and green. So that tells us they can't happen together. So the or tells us to add probabilities. The or means add. So what's our probability of picking a red on our first pick? So the favorable is 4. And the total, we add them all together. That's how many we have to pick from. 4 and 6 is 10, and 5 is 15. 4 out of 15. What's the probability of picking a green? on our first pick. We have 5 possible ones to pick from and still have 15. Now, because I'm going to add, I'm going to leave I could reduce the fraction, but because I'm adding, I'm going to leave this denominator as 15. So the probability of red or green, said or means add, so 4 out of 15 plus 5 out of 15 equals, I can add those because I have a common denominator, 9 out of 15. So that's why I didn't reduce that fraction. And can I reduce 9/15ths? How do I reduce it? Divide everything by 3, right? So I get 3/5. So I have 3 chances out of 5 to pick a red or a green. And the other way we could look at this is say, well, if I'm looking to pick a red or a green, I have 9 plus 5, I have 4 plus 5, I have 9 favorable marbles. Favorable marbles are either red or green. So 9 out of those marbles out of all 15 are favorable marbles. So we could add those two together and divide by the total. We can do it either way. But the idea with an or is we're adding. And probability means we multiply, or probability means we add. Questions on that example? So, what happens with probability is we get the rules for each part are pretty simple. We start combining them together, and we end up with all kinds of different rules for all kinds of different situations, and that's what makes it more confusing than it would seem. But if we try to keep these things together, and means multiply or means add, if we can keep our rules, try to keep our rules simple, that makes it a little easier to deal with all these probabilities. All right, we have one last thing to talk about today: overlapping events. So, what would you guess? What would you guess an overlapping event means? What are we talking about when we're talking about an overlapping event? So we said happens more than once. Yeah. So that's a good part. Yeah.
I was just going to say, is this still under independent?
This is still under, yes,
Okay.
still under independent. We're going to talk about dependent events, not in this section, but in a later section. So we know what dependent events are, but we're talking about probabilities of independent events today. Overlapping means something can happen more than once. So what we're talking about is outcomes that have outcomes in common, or they share outcomes. So an example would be, and we'll talk in just a second about how we calculate these probabilities. So we have a die, and we want the probability of rolling an even number or rolling more than 3 in one roll. So there's our keyword. We have or. So what are we going to guess? How are we going to work with these probabilities? Add. So it's going to have something to do with adding probabilities. But what What numbers on a die are even? 2, 4, and 6. What numbers are more than 3? So we have outcomes in common, or they share an outcome. 4 and 6. So we have to figure out how to deal with that. Because if we just add them together, we're going to count those twice. So we have to deal with that. So the 4 and the 6 are common to both outcomes. So we have to figure out how to deal with that probability. So our rule here, and we were right in thinking that the or meant we're going to be adding. What do you think we're going to have to do with that probability of the 4 and the 6 that we counted twice? How would we get rid of that? Well, we were talking about adding. Subtract. So we're going to add some things and we're going to subtract some things. So when we have overlapping events, we have to subtract some probabilities because we count them twice. So our probability. The way that we calculate our probabilities for overlapping events, we're going to say that A and B are overlapping. And I'll say overlap. So somewhere they share some things. We have some things that we'll count twice. Our rule for the probability of A or B. So just like we talked about here, we knew it had to do with adding. Probability of A plus the probability of B. That gives us all of these, but we count the 4 and the 6 twice. So we have to subtract the probability of A and B. So we have to subtract the part that we counted twice. So here, the probability of a 4 and a 6 are counted when we calculate the probability of even, and the 4 and 6 are counted when we calculate the probability of more than 3, so we have to subtract that out. So we don't double count them. We don't want to count them twice. We don't want to count that probability twice. So let's finish with this example. Let's calculate this probability. So what's the probability on my die of rolling an even number? 1/2, 3 out of 6, right? We have 2, 4, and 6. Can reduce that to 1/2. Because we're adding, I'm going to use this fraction. We can reduce it, that's fine. It will be fine either way. What's the probability of more than 3? We have 4, 5, and 6, so we have 3. So 3 out of 6, which is also 1/2. I'll leave this like that. So what is the probability? Now we need the overlapping part, the part that we count twice. Probability of even and more than 3. So how many numbers are even and more than 3? 2. Just 4 and 6. 4 and 6 are both even and more than 3. So we have two extra ones here, even and more than 3. So we have 2 out of 6. 2 of the numbers are even and more than 3. And we could reduce that if we wanted to 1/3, but I'll leave this so we can add our fractions more easily. So our probability now, using our rule of even or more than 3, is 1/2. Sorry, let me go back to my fractions. I want to use a common denominator here. 3/6 for this one, plus 3/6 minus 2/6. Probability of the even plus the probability more than 3. We're adding because we have an or probability, and then we're subtracting the ones that we count twice. So I get 3 plus 3 is 6, minus 2 is 4/6. And we can reduce that to 2/3. And that's my final answer. 2 chances out of 3 is rolling a number that's even or more than 3. What if we added up our probability and we got 4/3? What would that tell us? We did something wrong because 4/3 is more than 1. So that tells us our probability is more than 100%. So if you ever get a fraction that's more than 1, you ever get a probability that's more than 100%, you've made a mistake somewhere. All right, so we talked about 3 different kinds of probabilities. For independent events, the probability of one and the other happening, what do we do with our probabilities? For and probabilities? Multiply. And probabilities we multiply. For mutually exclusive events, events that can't happen together, probability one or the other, what do? For an or probability, add. For or probabilities we add, and then the overlapping events have one or the other, but we have some things in common. That or tells us we're going to add, but we have to subtract the part that they share. So we learned 3 different rules today. And probabilities we multiply, or probabilities we add, and mutually exclusive or overlapping events we add the probabilities and then subtract the parts that they share. All right, questions? Okay. Stop this.